So in today's class, I want to introduce you a very simple concept, which is called as equilibrium. So, so, so please try to understand what you have. If you have your coordinate frame, you have X, you have Y. Sometimes you deal with a 3D coordinate frame, which means you have X, you have Y, and you have Z. X, Y, and Z. We always use right hand coordinate system. Right hand system. Now, what is this right hand system? So if you look at the three fingers on the right hand side, this thumb is going to be X. First finger is going to be Y, and the middle finger is going to be Z. So X, Y, and Z. And please remember this, because when you look at the three-dimensional force systems or two-dimensional movement system, this coordinate frame can be oriented in any ways. Anytime you have any questions, remember, so this is your X, that's your Y, and Z is coming up. So look at the coordinate frame that I have drawn. X towards the positive X-axis, first finger towards the positive Y-axis, and the middle finger towards the positive Z-axis. Everyone understood this? Now, in addition to that, there is the concept which is called as curve or the movement or the rotation. Now, I want you to follow this guideline. If you curve your fingers in the direction of rotation, and if your thumb is aligned with the positive X, positive Y, or positive Z, that rotation or that curve is positive. So, for an example, I'm going to show you that this is rotated like this. Now, I want you to notice, curl your fingers in the direction of rotation. Can you see that your thumb is pointing towards the negative X-axis? Are you with me? So this rotation is negative. Now, if you curl your fingers, something like this, rotation, rotate, rotation, curl your fingers, and you notice the thumb is pointing towards positive X-axis. So this rotation is positive. Similarly, if you look at the rotation about Y, curl your fingers in the direction of rotation. Can you see that this is a positive rotation? Curl your fingers in the direction of Z. Can you see that this is going to be a positive rotation? Everyone understood this? This is negative. This is negative. Are you with me so far? Now, this allows me to define something called as the conditions of equilibrium. And before I do that, I just want to talk about forces and moments. So if you have an object, you apply a force, the object accelerates by the Newton's law of motion. Force is equal to mass times acceleration. Now, I want you to understand, if this object is pivoted, for an example, there is a hinge, then what's going to happen is this force will be acting at a distance I'm gonna call this R. So please note, this force and this distance, they are perpendicular to each other. This is gonna give you a moment. So this will give you a moment. Moment is given as force times distance, but this distance needs to be perpendicular. This force times the distance, this distance needs to be perpendicular. Now, I want to show you something very important. So imagine this. This is again, you apply the force, you rotate. So there is some type of moment. You apply the force, you rotate. You apply the force, you rotate. However, this moment is called as the bending moment. This moment is called as the bending moment, and this moment is called as the twisting moment. So please understand, if the moment is about an axis, that is called as the twisting moment or torque. So bending moment is perpendicular to this pivot point. And on the other hand, if you think about it, if you have a shaft, and on this shaft, there is a force, and that is basically twisting the shaft, and that is called as the twisting moment or torque. So this is the case for torque. So you can have moment is force times the perpendicular distance. This equation is valid for the bending moment. This equation is valid for the twisting moment, but the bending moment is around an axis, and twisting moment is above an axis. So torque is nothing but the twisting moment. Now imagine if you have an object, if there are no forces acting on the object, so for example, this is the object. On this object, there are no forces. You agree with me that this object is not going to go anywhere. It means if the forces acting on this object, they could be in x direction, they could be in y direction, or they could be in z direction. If there are no forces acting on this object, the object will be stationary, or it will be in the state of static equilibrium. Alternatively, if all the forces cancel each other out, then also the object will be in static equilibrium. It means, for example, if you have 5 Newton of force going towards positive x-axis and 5 Newtons of force going towards negative x-axis, these two 5 Newton forces are collinear, the same line, then that object is not going to move. Is it understood this? So this gives me, it actually is the crux of next chapter. This tells me summation of forces. So static equilibrium is achieved when summation of forces in x direction is equal to 0, summation of forces in y direction is equal to 0, summation of forces in z direction is equal to 0. It means if all the forces balance each other, then that object is going to be in static equilibrium, force static equilibrium. Do you agree with me? Any questions about that? Similarly, if all the counterclockwise movement are cancelled by clockwise movement, then the object will be in moment equilibrium. What do I mean? For example, I want you to look at the triad that I have drawn. If the clockwise star, which is shown by the green arrow, has the same magnitude as the counterclockwise star, which is shown by the negative red arrow, if their magnitudes are the same, the total torque or the total moment is going to be zero. It means that object is not going to rotate. You agree with me? So the object would be in static equilibrium. This is the force equilibrium. The force. If summation of moment about x is equal to 0, summation of moment about y is equal to 0, summation of moment about z is equal to 0, then the object is in static equilibrium or static moment equilibrium. Do you agree with me? This is a very, very important concept. Now, please try to understand. Whenever we are talking about statics, the whole statics is captured in these 6 equations. Forces in x direction cancel each other. Forces in y direction cancel each other. Forces in z direction cancel each other. Moment about x. So please understand, this is not moment about any other axis, but this is moment about x. Moment about x, the sum of moments about x is 0. Sum of moment about y is equal to 0. Sum of moment about z is equal to 0. Everyone understood this? Now I want to give you a very simple problem. And so think about this is called as a bell crank lever. And there's a history why this is called as the bell crank lever. I don't know. Have you seen those old church bells? So basically, there is a dong here, and then there is this bell here. And if you, what they do is there is this rope, you pull the rope, and basically this guy hits the bell, and then it makes a noise. So that's why this is called as the bell crank lever, which means 2 of these arms are perpendicular to each other. Now, I want to ask you this question. If the force, so I'm going to give you some distances. This distance is 2 meters. This distance is 1.5 meters. And what I'm going to say is the weight or the force acting here, is 10 newtons. Now, my question to you is, what should be the force acting here so that this bell crank lever is in equilibrium? Now, this is the bell crank lever. You are applying 10 newtons of force over here. And I want to find out the magnitude of force F over here. If this bell crank lever is in static equilibrium, the first and foremost, what I want to do is I want to set up the coordinate frame. So this is going to be my x. This is going to be my y. And this is going to be my z. Do you agree with me? Now, I want you to understand that this is the hinge. If I want this bell crank lever to be vertical, horizontal in this position, do you agree with me that the moment that is given by this force, should cancel out the moment given by this force? Do you agree with me? In other words, what I'm going to do is I'm going to find out the moment about this hinge O. I'm going to find out the moment about hinge O. So I'm going to say summation of moment about Z is equal to 0. Summation of moment about Z is equal to 0. Now I want you to tell me can you see that this force is going down? If I look at the moment given by this force, this is the force multiplied by this distance. Can you see that this movement, if I curl my fingers in the direction of movement, and my thumb is in the opposite z direction. Can you see that my movement is like this? Yeah. Right. Okay. This is the hint. This is the force. You agree with me? It's going to rotate like this. If this is going to rotate like this, curl your fingers in the direction of rotation. And can you see that the thumb is in the opposite direction to the positive z-axis? It means this moment is negative. Everyone understood this? So this movement is like this. Curl your fingers in the direction of movement. And when you do that, you see that your thumb is going towards board. Z is coming out of the board. Thumb is going inside the board. So this moment is negative. So I'm going to call this 10 multiplied by 1.5. I'm going to add a negative sign. You agree with me? Now I want you to look at this force. Now look at the moment given by this force. Can you see the moment given by this force in this direction? Curl your fingers in the direction of rotation or direction of movement. Your thumb is coming out of the board. You agree with me? Which means that movement is positive. Why that movement is positive? Because when you curl your fingers in the direction of movement, your thumb is in the same axis or in the same direction as positive z. So it's going to be plus f times 2 is equal to 0. Now, once you solve this, you get the value of f at 7.5 meters. You agree with me? So, what we studied today is we looked at the condition of static equilibrium. Summation of forces in x direction is equal to 0, y direction is equal to 0, z direction is equal to 0. Then all the forces are cancelling each other. Summation of moment about x is equal to 0, about y is equal to 0, about z is equal to 0. Even all the moments are cancelling each other. Any questions? Concerns, thoughts, ideas, doubts? Now, the concept that we studied can be used to solve this problem. This problem can be solved by three techniques. I'm going to solve this problem, the technique that is not shown in the solution. Now, I want you to take a look at this problem. This is called a truss. Why it's called a truss? Because two or more members are attached to each other. So basically, this is called as a truss. Now, I want you to look at this problem, and I want you to tell me that this whole truss is not going anywhere. So do you agree with me that this truss is in static equilibrium condition? Agree with me? This truss is in static equilibrium condition, which means forces in the x direction, forces in the y direction, they cancel each other. There is no z direction because we have two-dimensional truss. It is not a three-dimensional truss. There is a two-dimensional truss. So what I want to do is I want to find out the forces along the member AB. So I want to find out the forces along the member AB, and I want to find out the forces along the member AC. You agree with me? This problem is very, very important. And before I start solving the problem, I want you just to tell me this force at A is coming down. Okay, the force at A is coming down. Because of this force, is member AB elongated or compressed? What do you think? Because of that force F coming down, member AB, is it elongated or is it compressed? Okay. Elongated. You agree with me? Now, because of this force F going down, what is happening to the member AC? Is it elongated or is it compressed? Compressed. Compressed. Everyone understood this? So wherever you have elongation, that is called as tensile force. If you are pulling, that is called as the tensile force. Whenever you have a member where the forces are going inward, that is called as compressive force. So please try to understand. So let's start with this. We have a tensile force here, and we have a compressive force here. Now, do you agree with me that this entire truss is interconnected? This truss is in equilibrium. Now, what I want to do is, and everyone please get it, it's a very important concept. I want to free each and every member. So this, if you look at AB, AC, and BC, they are hinged together, so they are connected. So now I want to free these bodies, and I want to draw a diagram by freeing these bodies. That is called as the free body diagram. Everyone understood? That is called as the free body diagram. And everyone just pay attention. It's extremely important, and I want you to understand this concept very well. So I'm going to start something like this. This is going to be my point A. This is going to be my point B. And this is going to be my point C. And what I'm going to do is, I'm going to free the member. 1, 2, and maybe I'll just keep this member. Since this is the wall, I'll just keep this as this. So I have A, I have B, and I have C. Now I want to find out the forces. Remember, just by looking at the problem, you told me that this member AB needs to be in tension. You also told me that this member AC needs to be in compression. Do you agree with me? So what I'm going to do is, first I'm going to draw the forces. So I have this force going down F. I have this force which is going down F. And this force is compensated or cancelled by this force, which is FAB. And this force is compensated by the reaction force in the member FAB. Now this AB member is also in equilibrium. It means the forces on the member AB needs to be in equilibrium. Note, joint is in equilibrium, each member is in equilibrium. So if I were to look at the member equilibrium, then it's going to have force like this and force like this. Similarly, if you look at the force BC, it's going to be something like this. So please note, and some of you may ask me, how did I come up with this direction? I came up with this direction from a simple logic. Because as you said, AB is in tension. If AB is in tension, which means that member needs to be pulled from both sides. But I have freed the joint. As soon as I free the joint, these virtual forces, they come in the picture. Can you see that FAB and FAB? Those two forces have equal magnitude. but opposite direction. Which means right now I have freed the body. If I were to combine the body together, if I were to add everything, you see that I get those, I just get that truss over here. Yeah, agree with me? If you look at that truss, it's extremely important. The only thing on that truss is the external force F. But because of the external force F, internal forces FAB and FBC are generated. FAB and FBC are generated. FBC. FBC. FAB and FAB. If you combine these forces, if you actually bring, instead of breaking the joint, you combine these forces, then please note this force cancels with this force cancels with this force. If you connect this joint to this joint, this force cancels with this force, and that force cancels with the top force. AC. Yeah, what happened to AC? AC. Oh yeah, that is the AC, not BC. You're right. This is AC. Correct. AC. FAC. This is FAC. FAC. Everyone understood this? Now what I want to do is, I want to find out the magnitude of forces. And to find magnitude of forces, I'm going to start with this. This angle is 30 degrees. Do you agree with me? This angle is 90 degrees. So do you agree with me that this angle is 60 degrees? Are you with me? So check this out. Look at the truss. This angle is 30 degrees. This is a 90 degree. So the remaining angle has to be 60 degrees. Now I'm going to do the same analysis over here. So please note, this angle is 45 degrees. So do you agree with me that this angle has to be 45 degrees? So just for clarity, I'm going to draw this force system again. You have force F going down. You have one more force, which is at 60 degrees. And you have one more force. This force is up. One more force. This is FAC. And you have this force, FAB. So this angle is 45 degrees. Are you with me so far? Now what I want to do is, I think the value of F is given. Magnitude of F is given. F is equal to 500 newtons. Can someone tell me, how should I solve the problem? There are two ways this problem can be solved. Tell me, how would you solve it? I can feel it. Yes, I will. Tell me, how would you solve the problem? You try to understand. This is a vector equation. This is a vector equation. So you can't just add dollars to bases, dollars to dollars, pesos to pesos. In other words, what I need to do is, I need to find out component of the forces in x direction. I need to find out the component of forces in y direction. Since this whole system is in static equilibrium, summation of all the forces in x direction is equal to 0. Summation of all the forces in y direction is equal to 0. Everyone understood this? So whenever you solve the problem, first show the coordinate system. Okay, I'm gonna set up the coordinate system right here. So this is going to be my positive x. This is going to be my positive y. You agree with me? I'm gonna write down summation of forces in x direction is equal to 0. So what I need to do is I want to find out the component of FAB in the x direction. I want to find out component of FAC in x direction. Are there any other forces in x direction? So tell me, how do I find out component of FAB in x direction and what would be its sign? How do you do components? Draw a vertical. So do you agree with me? I would have FAB cosine 45. Everyone okay with cosine? Is there anyone who doesn't understand why cosine? Because this is a right angle triangle. This is FAB. I want to find out this guy. This is going to be FAB cosine of theta, if this angle is theta. This is going to be FAB sine of theta. Do you agree with me? And if my FAB is going in this direction, you place your coordinate system, coordinate frame here, and this tells me that my cosine component is in this direction and my sine component is in this direction. Everyone understood this? Clear? Okay. So I would say FAB cosine 45. Now what happens to FAC? So FAC is in this direction. And if I want to find out its component, I'm going to draw, this is FAC. And this angle is 60 degrees. So I think it just might be easier if I complete this triangle here. So this is going to be FAB, FAC, cosine 60, cosine theta 2, FAC, sine theta 2. Do you agree with me? So I have FAB cosine 60, and then I'm going to have minus FAC sine 60 is equal to 0. Calculators, tell me what is cosine 45? What is cosine 45? 1 over root 2? Root 2 over 2. So FAB root 2. Yeah, root 2 over 2 is 1 divided by root 2. Minus, what is sine 60? What is sine 60? Root 3 by 2, right? Is equal to 0. So I have an equation, square root of 2 FAB minus square root of 3 FAC is equal to 0. In other words, I know that FAB is equal to square root of 3 divided by square root of 2 FAC. Do you agree with me? Now, this whole thing, this expression, we derived because summation of forces in x direction is equal to 0. I still have to use one more equation, which is summation of forces in the y direction is equal to 0. Summation of forces in the y direction is equal to 0. Now let's see, this force 500, is it going up or going down? Down. So is it positive or negative? Negative. So I have minus 500. Do you agree with me? I have the cosine component of FAC. So do you agree with me that FAC, so this component by the way. So plus FAC cosine 60. And then I have one more component, which is FAB sine theta. So plus FAB sine 55 is equal to 0. Now tell me, what is cosine 60? Cosine 60 is 1/2, right? Sine 45, again, square root of 2 plus 2. So plus FAB square root of 2 by 2 is equal to 500. You agree with me? Now note, I have two equations and I have two unknowns. Can I solve this problem? The answer to that question is yes. What would I do? FAB is equal to square root of 3 by 2 FAC. FAB is equal to square root of 2 FAC. So I'm going to replace this FAB by square root of 3 by 2 FAC. So I'm going to replace this guy square root of 3 by 2 FAC square root of 2 by 2 plus FAC 1 divided by 2 is equal to 500. You agree with me? You can solve this expression and tell me the value of FAC. Once you know FAC, you can plug this value in this expression and tell me the value of FAB. Are you with me so far? Once again, let me explain. You have a truss. By the way, there is an entire chapter on truss that just deals with this. So make sure that you understand this. So what you have, this is also called as method of joints. All the joints are in equilibrium. It means all the forces in x direction and y direction and z direction will cancel each other out. So we found the forces in the x direction. Summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0. These two expressions give me two equations. I have two unknowns and I have two equations. So I can solve them. Everyone understood this? Okay. Now I took the scenic route. There is one more way of solving this problem. And that simply is based on the triangle principle. Okay. And you know this, you have studied this. So if you have a triangle, this length is A this length is B and this length is C. This length is A, this length is B, and this length is C. From geometry, we know that the length of from geometry, we know that the length of the triangle is proportional. The length of the triangle is proportional to the angle that it prescribes. In other words, if this angle is alpha, if this angle is beta, and if this angle is gamma, then A divided by sine alpha is equal to B divided by sine beta is equal to C divided by sine gamma. Are you with me? If you don't believe me, just imagine you start shrinking A. You agree with me that angle alpha would be proportionately reduced. Just imagine in your mind if length B, okay, imagine if length B is equal to length C, if length B is equal to length C, length B is equal to length C, what would be the angle alpha and what would be the angle beta? If length A, and you know this. If length B is equal to length C, you agree with me, this is going to be 45 degrees. This is going to be 45 degrees. And this guy is going to be 90 degrees. In other words, what I can do now is I want you to look at this force triad. Why is it called a triad? Because three forces. You can only use this trick when you have three forces. If you have two forces, four forces, five forces, six forces, you cannot use this trick. If you have a force triad and all these three forces are passing to the same point, then what you can do is you can construct something called as the force triangle. How do you construct the force triangle? I want you to focus on joint A. You have this force F. Then what you have is basically you have this force which is FAC. And what you have is you have this force which is FAB. Now, this forms a force triangle. Do you agree with me? And it is extremely important to understand that that force F that is going in the downward direction, part of that force is taken by FAB, part of that force is taken by FAC. In other words, my vector expression is still valid. FAB plus FAC is equal to F. Do you agree with me? This is the vector expression. And now what I'm going to do is I'm going to do the simple trick. Now what I want you to tell me is I want you to tell me these angles. From the geometry of the figure, you should be able to find out what these angles are. And I can tell you the easiest way to do that is this is 30 degrees, So this angle is going to be 60 degrees. You agree with me? If this angle is 60 degrees, which means this angle okay. If this angle is 60 degrees, then this angle is going to be 60 degrees. Now, this angle, if you look at this angle is going to be 45 degrees. And if this is 60 degrees, this is 45 degrees, can someone tell me what is this angle going to be? And make sure you understood how I calculate angle. Once again, this angle is 30 degrees. You agree with me? That angle is 30 degrees. It means the top angle is 60 degrees. If that angle is 60 degrees, this angle is 60 degrees. You agree with me? If that the top angle, angle B, is 45 degrees, what you have is that AB is coming like this. If AB is coming like this, that angle is 45 degrees. So this angle has to be 45 degrees. Correct. At the end of the day, the equation should be satisfied. And now you can solve this problem in one line. Because remember, we know A divided by sine alpha, B divided by sine beta, and C divided by sine gamma. So can I write down something like this? Now I'm going to use here. I can write down FAB divided by sine divided by sine 60 is equal to FAC divided by sine 45 is equal to F divided by sine 75. S stands for sine. And as you know, this F guy is 500. 500. So can you tell me the values of FAB and values of FAC? You can solve this problem using the triangle relationship because there are only 3 forces. If you had 4, 5, 6, you cannot use this triangle forces. You'll have to go through the regular process. So in today's class, what we discussed conditions of static equilibrium, summation of forces and summation of moments. If all of them go to 0, the object is not going anywhere. We looked at a simple problem of moments equilibrium. If you want to find out this force, you need to take the moment about this thing, and then that gives you the value of the force. And then we actually, believe it or not, I actually taught you 2 chapters. This example. First chapter I taught you is the condition of equilibrium, which is chapter 3 in your textbook. And the process is method of joints. It's chapter 7. So it's one simple example. The word 2 chapters. but we solve a lot more problems. I want you to take a look at the problem and tell me if there are any questions. Everyone understood everything? Yeah. So going back to the solve. So actually that is. Yeah, AC answer is given here. I can't see. I mean, actually, this problem is solved in your notes, by the way. And FAB is 448. And by both techniques, you should get the same answer. Yeah, question?
So you say that, or it seems that there can be other options, but the forces on them, like four forces acting on the one side, 4, 5, 6, 7, 8. So you would just repeat, you don't use law of sine, you know, that first line that we did, and just repeat.
Law of sines can only be used when you can form a triangle. Because law of sines is based on the trigonometric fact that the length of the side is proportional to the sine of the angle opposite. As long as it's not triangle, then what you can do is if you have a lot more forces, then you basically slice them in triangle. We'll talk about it later, but I want you to understand these concepts. Okay, with that, I want to assign you a homework. So I want to assign problem 2.3 as homework. So yeah, it is actually, I have given you the solution of this problem, but you guys know how to solve this. First, try to work this problem out. And I don't know, this problem is actually very simple. I'll just set it up. Two forces are applied at the end of the screw eye in order to remove the force. We have to find out the angle theta in such a way that the resultant F, the total force F acting on the force is directed vertically upwards and has the magnitude of 750 newtons. How would you solve this problem? This problem, again, remember, there are three forces involved. So you can solve this problem using summation of forces in x and y is equal to 0. Or you can solve this same problem using the triangle equation that we got. Everyone understood this? If you solve this problem by both techniques, your answer will be the same. So this is your homework problem. And I'm going to give you this problem, which is 2.6, also as homework. So by the time you come next week, make sure you have worked out these few problems. Yeah. No, you don't submit it. You solve it and grok it. In the word, internalize it. But who knows? I may ask you a similar question in the quiz. There is going to be another quiz next week. Okay. Now, what I want to do is, quiz should be up. It's 4 o'clock. Open the quiz on Canvas. You can use your calculator. You can see the problem on your phone. Then work that problem out on a piece of paper. Take the picture of your solution and upload it to the Canvas. And I'm gonna keep an eye on you to make sure that ChatGPT does not pop up. Canvas. You don't have to look at the problem, solve the problem on a piece of paper, and upload your solution on the Canvas. And this is going to end at 4:15. So if you take more time. The upload will end at 4:15. With this. 5 minutes, total 5 minutes. Yeah, of course. You already invested how much time? Oh, 1 minute.